Okay guys, welcome back. We are going to move on to the second section of the packet, which is expressions and equations. I'm going to be doing 7 and 11 and 14. So if you had problems with those or problems on other ones specifically, I'd watch this and then attempt those again. The first one that we're going to be starting out with is a little bit more abstract. We didn't talk about this specifically when we went through expressions and equations at the beginning in quarter one, but if you just use some simple experimentation, it's not too difficult to figure out. So what it's asking you, it gives you a whole equation, an area equation for a right rectangular prism, and it says which term of this formula is not dependent on the height. And this whole problem really hinges around this word dependent. What it really means is if you change the value for h, if you change the value of the height, what else changes? Does anything else change? So what you can do is kind of experiment by changing the value of the height. And you might be asking yourself, well, they didn't give us a value for the height. Well, you can give yourself a value for the height and then change it and see what happens. So when I was trying to figure out how I could demonstrate this problem, I originally did it where I did it with one h and then another h and did all of these options, 1, 2, 3, and 4. But I think you can actually get the gist by just doing it with just a couple of these. So I'm going to choose maybe 2, and I think you'll understand kind of what I mean. So I'm going to set h as just an arbitrary number. So I'm going to pick 2. So if I set h as 2, and I'm also going to assign a value to the L and W, maybe I'll set L to be 1, and I'll make W 3. Okay. I'm not going to set a value for A because I can get A using the 2, 1, and 3 if I plug those into this formula, right? So I need to figure out which of these is not dependent on height. So when you see a problem that says not, you know that 3 of the answers are going to be true to the opposite question. So which term of this formula is dependent on height? 3 of those answers must be correct for that question. So if I change height, 3 of these must be true. So I'm going to just pick 2 at random. I'm going to pick number 2 and number 3, right? So 2 times L times W. So if I do 2 times L, which is 1, times W, which is 3, then I have 2 times 1 times 3. 2 times 1 is just 2, and 2 times 3 is 6, right? And then I'm going to do it again for 2HW. If I want to do 2HW, then I'm going to put 2 into here, and a W, which is 3. So 2 times 2 is 4. 4 times 3 is 12. Okay, so that's our first iteration. So that's when we had h as 2. Now we're going to go back to the central objective of the problem, which is what happens when we change height. Which of these changes if we change height? And again, we're just going to be looking at these 2. So we're going to change height to maybe 4. I'll double it. So if I double it to 4, I'll make h equal 4. And I have to keep L and W as the same because the question isn't asking me which terms of this formula is not dependent on height, length, and width. It's which term of this formula is not dependent on height. So the only thing I can change is height. So I'm going to keep L the same. So L equals 1, W equals 3. And I'm going to plug it in again. I'm going to do 2LW. So 2, L is 1, and W is 3. And again, I'm going to end up with 6. And I'm going to do 2HW, so 2, 4, and 3. 2 times 4 is 8. 8 times 3 is 24. So now we kind of get into sort of the abstract thinking. So over here, when we had h set as 2, we didn't actually put the 2. We didn't actually enter in or substitute for h because h was not a part of the term. Only L and W were a part of the term. So we got a 6, and then we got another 6 over here. When h was a part of the term, then we got a different number. So we can generalize that thought, and we can say when h is a part of the term, then it is dependent upon the height. Basically, that means if h is in the answer, if you change h, the answer will change, right? We changed h, and our answer changed from 12 to 24. So we need to figure out which of these answers does not have an h, right? So this one has an h, so that's not going to be it. This one has an h, that's not going to be it. A and 2LW do not physically read the letter h, right? It does not have the letter h here. But we can go back and we can look at what does A mean. A is equal to all of these terms added together. And 2 of these terms have the letter H in them. So A is equal to a bunch of things, 2 of which have H as a part of them. So A is also going to be dependent upon height. So our answer is going to be 2LW. And if you want to test this concept further, you can use these numbers or really any numbers that you pick and just change H, and you can do it for each of these options. And if you're calculating correctly, you should see that the only time the answer changes is with numbers 3, 4, and 1. It should not change with numbers 2, like how we had here. It has 6 and 6. It did not change. And if you want me to do that full calculation on another video, I can do that as well. I just wanted to kind of keep it short and only do these 2. So now we're going to move on to problem 11. This one is a word problem. So let's see, I'm going to put it here. So it says Connor wants to burn 250 calories while exercising for 45 minutes at the gym. On the treadmill, he can burn 6 calories per minute. I'm going to underline some of these numbers because they seem important. 250 calories, 45 minutes, 6 calories per minute. On the stationary bike, he can burn 5 calories per minute. If T represents the number of minutes on the treadmill and B represents the number of minutes on the stationary bike, which expression represents the number of calories that Connor can burn on the stationary bike? Okay. So basically, Connor is going to the gym and he's exercising on 2 different equipments. He's exercising on a treadmill. I'll make a column for treadmill. And a bike. We don't know how long he's exercising on each of those equipments, but we know the total is going to be 45 minutes. So he could be exercising for 5 minutes on the treadmill and 40 minutes on the bike, or 20 minutes on the treadmill and 25 minutes on the bike. We don't know anything about that. We just know that he wants to exercise for a total of 45 minutes, and he wants it to equal 250 calories. So what we should do is set up basically a system of equations. So we should set up a system of equations where time on the treadmill plus time on the bike is 45, and then time on the treadmill times the calories burned plus time on the bike times the calories burned equals 250, right? So we need to figure out kind of what our variables are going to be. So if we have 6 calories per minute on the treadmill, I'm going to put that here, 6 calories per minute on the treadmill. So if it's 6 calories per minute, you are going to be multiplying that by the number of minutes, right? And we'll call that X. So we'll call the X will be the number of minutes on the treadmill. And same for here, 5 calories per minute. We're going to multiply that number by the number of minutes that he's on the bike. So we'll have y be the number of minutes that he's on the bike. And then we'll have x plus y, right? The number of minutes on the treadmill plus the number of minutes on the bike equal a total of 45. I'm going to get another piece of paper. Hopefully you can see this okay. Okay, so x plus y equals 45. And then 6 calories per minute times x plus 5 calories per minute times y equals 250 for the total number of calories. And what we really want to find is the expression that represents the number of calories he can burn on the stationary bike. So what we're really interested in is this one here. We're more interested in y. So what I would do first is I would use the process of substitution. So you have an x and a y that are kind of by themselves. So you can pretty easily set the equation equal to x or equal to y, and you can get the other one. I want y, so in order to get y, I need to set this equation equal to x so that I can plug in the result into here and solve for y. So if I want to get x alone, I'm going to rewrite it here. X plus y equals 45. Hopefully you guys can see that. I want to get x alone. So what's in my way? The y is in my way. How do I get rid of a positive y? I can subtract y on both sides. So x equals, this cancels out, 45 minus y. And then I would substitute this into my x over here, my x. So I'm going to do that. So 6 times, let's reposition. Okay, yeah. So 6 times 45 minus y plus 5y equals 250. And from here, we're solving an equation. So 6 times 45 is 270. And then 6 times negative y is negative 6y. Plus 5y equals 250. So we can combine negative 6y and a positive 5y to be negative y. So 270 minus 1y, right? And you can write the 1y if you need to. Minus 1y equals 250. From there, I'm going to combine my constants, 270 and 250. And this will be negative 1y on this side and a negative 20 on this side, right? 250 minus 270 is negative 20. And then from here, I can divide by the negative 1 on both sides. I'll write that over here. Negative 1y equals negative 20. I just rewrote what was down here, and then I'm going to divide by negative 1 on both sides to get rid of my negative. So now I have y equals 20. Negative 20 divided by negative 1 is 20, right? So now we have to think to ourselves, what does that y mean? If we go back to what we wrote next to our problem, our y is the number of minutes that we were on the bike. So I'm going to write 20 minutes that we were on the bike. And from here, we need to figure out how many calories that Connor was on the bike. So how do we figure out how many calories he burned while he was on the bike? Well, they gave us that conversion. It said on the stationary bike, he can burn 5 calories per minute. So 5 calories per minute times 20 minutes. And that would be 5 calories per minute times 20 minutes. That would be 100 calories. Oops, can you guys see that? 100 calories. Okay, so now that we know how much he burned, we can look at our options and see which answer matches that 100 calories. So it looks like they set B as the number of minutes on the stationary bike, and that's fine. We just set it as, I think we set it as Y. Yeah, so we set it as Y. So we're just, instead of the B, we're thinking about it as a Y. So the first one, it just says Y, right? Or it says B. So if we think about it with our letters, that's just Y. And we got Y equals 20. So what we're looking for is which expression represents the number of calories. The number of calories is 100. So if this equals 20, 20 does not equal 100. So 1 is not correct. Here we have 5 times B, or 5 times Y. If Y is 20, and 5 times 20 is 100, then that would match, right? We did 5 times 20 to get 100 calories. So that would match. And this is a multiple choice question, so you can just stop here and circle this. If you want to go through and answer the other ones, you can check these as well. 45 minus 20, well, that equals 25. He didn't burn 25 calories, he burned 100 calories. So this one would not be correct. 250 minus 5B, or 5Y. So 250 minus 5Y would be 250 minus 100, right? 5 times 20 would be 100. So 250 minus 100 is 150. That's not 100, that's not the answer we wanted, so that's not correct. So it would be number 2. That one was sort of a longer one, depending on how you did it. Also, if you had Desmos on this particular packet, you could have also solved this system of equations via Desmos, but I tend to want to solve it by hand. That's number 11, and then the last one we'll do is number 14. Okay, maybe I can zoom in a little. Okay, so students were asked to write 6x to the 5th plus 8x minus 3x to the 3rd plus 7x to the 7th in standard form. Shown below are 4 responses, and it says which student is correct. You may not remember what standard form is, but it's super, super easy. Standard form just means that the exponent that's the highest is first, right? So the exponent is that little number that's in the superscript. So 5 or 3 or 7 in this case, right? When it's a squared, the number is 2. So which of the small superscript numbers, whichever one is biggest, that one has to be first. So we have a 5 and a 3 and a 7 as our exponents. So which of those is the biggest? The 7 is the biggest. So we need to figure out which one has the 7 as the start. And then from there, it needs to decrease in that order. So it needs to go 7x to the 7th, and then the 6x to the 5th, then the 3x to the 3rd, and then the 8x. It needs to go down in order. So which one has the 7x to the 7th as our first? Anne, well, Anne has it. Bob does not have it. Carrie does not have it. And Dylan does not have it. It looks like Anne is the only one who has it. So the correct answer is number 1. So that one was pretty short. So that's all I have for this section of the packet. The next problem section that we're going to be doing will be this solving linear equations, which shouldn't be too difficult except for the fact that there are a lot of fractions. So get ready for that soon, and I'll see you soon.